More than 2,000 years ago, in a remote valley cradled between two mountain ranges, ancient builders quarried, carved, and moved stones so massive that no crane on Earth today could lift them. Not one, not even close. Some of these blocks weigh as much as 3 fully loaded Boeing 747 airplanes. They were cut from solid bedrock, transported hundreds of meters, and lifted into position atop a platform that still, to this day, leaves engineers staring in disbelief. Welcome to Baalbek, one of the most staggering and least understood engineering mysteries on the planet. This is not a myth. This is not exaggeration. This is measurable, physical stone, sitting exactly where it was placed thousands of years ago, defying every conventional explanation of ancient technology. And the strangest part is this. Nobody, not archaeologists, not structural engineers, not historians, can fully agree on how it was done. Today, we are going to walk through one of history's greatest unsolved engineering puzzles. We will explore the civilizations that built here, the impossible stones they left behind, the modern science that has tried and often failed to explain them, and the myths that have grown around a site so extraordinary that some people have even questioned whether it was built by human hands at all. The story begins in the Bekaa Valley, a fertile strip of land in modern-day Lebanon, sitting between the Lebanon Mountains to the west and the anti-Lebanon Range to the east. This valley has been a crossroads of civilization for thousands of years, a natural corridor connecting the Mediterranean coast to the interior of the Middle East. Long before Rome ever set foot here, this land was sacred. Local Phoenician communities worshipped a sky and storm deity here, a god they called Baal, and the site itself carried religious significance that predates written history. When the Romans arrived and absorbed this region into their empire, they didn't build here randomly. They built on top of something already considered holy ground, transforming the site into one of the largest and most extravagant religious complexes anywhere in the Roman world. They called it Heliopolis, the city of the sun, and they dedicated it primarily to Jupiter, the king of their gods. Construction is believed to have started sometime in the 1st century BCE and continued for roughly 2 centuries, involving multiple emperors, enormous resources, and, by some estimates, tens of thousands of workers. The finished temple complex was designed to be the largest religious structure in the entire Roman Empire, larger even than anything built in Rome itself. But here is where the story stops being ordinary Roman history and becomes something far stranger. The visual, close-up shots of the enormous stone blocks forming the base of the temple platform, scale shown with a human figure standing beside them. Underneath the temple, forming part of its foundation platform, sit stones that dwarf anything else the Romans are known to have built anywhere else in their empire. These are called the trilithon stones, 3 colossal blocks of limestone stacked side by side, each one measuring roughly 19 meters in length, over 4 meters in height, and estimated to weigh close to 800 tons apiece. 800 tons. To put that into perspective, that is heavier than 2 fully loaded Airbus A380 aircraft combined per stone. And there are 3 of them, sitting in a row, fitted together with a precision that leaves barely any gap between the joints. Visual engineering diagram overlay comparing the trilithon stone weight to modern vehicles, aircraft, and cranes. As if that wasn't enough, nearby in an ancient quarry lies an even larger stone, one that was never actually moved into position. Known as the Stone of the Pregnant Woman, or Hajar al-Hibla in Arabic, this block weighs an estimated 1,000 tons. And in more recent excavations, archaeologists uncovered an even larger stone, still buried partially in the same quarry, nicknamed the Stone of the South, estimated at a staggering 1,650 tons. To understand just how extreme this is, consider that modern construction cranes, some of the most powerful lifting machines ever built by human engineers, typically max out around 1,000 to 2,000 tons of lifting capacity, and those machines require massive counterweights, hydraulic systems, and steel cabling that simply did not exist in the ancient world. So the question that has haunted engineers, historians, and archaeologists for centuries is deceptively simple. How did people 2,000 years ago quarry, transport, and place stones this heavy, using nothing but ropes, wood, muscle, and simple machines? Let's start with what we do know, because Roman engineering, even without modern machinery, was extraordinarily advanced for its time. Roman builders were master quarrymen. Using iron chisels, wedges, and hammers, they would cut a groove around the perimeter of a stone block while it was still attached to the bedrock. Wooden wedges would then be driven into these grooves and soaked with water, causing the wood to expand and gradually crack the stone away from the surrounding rock along a controlled fracture line. This method allowed for surprisingly clean, straight cuts, even on an enormous scale. Once free from the bedrock, the real challenge began. Moving these blocks from the quarry to the construction site, a distance of several hundred meters, much of it uphill. The most widely accepted theory suggests that Roman engineers used a system of wooden rollers, sledges, and lubricated tracks, possibly using materials like animal fat or wet clay to reduce friction. Ropes made from hemp or palm fiber, some estimated to require thousands of workers pulling in coordinated unison, would have hauled these stones slowly across specially prepared roadways. Some engineering historians propose that teams of oxen, potentially hundreds of them working with pulley systems, may have provided additional pulling power beyond human muscle alone. Once the stones arrived at the construction site, lifting them into position presented an entirely different problem. For this, Roman engineers are believed to have used massive earthen ramps, gradually built up alongside the temple platform, allowing workers to drag the stones upward using the same roller and rope systems, inch by inch, until they reached the required height. Some researchers also suggest the possible use of massive wooden cranes, similar to those depicted in Roman relief carvings elsewhere in the empire, though scaling such devices to handle loads of this magnitude would have required engineering far beyond anything else documented from this era. In recent years, structural engineers and archaeologists have used advanced technology, including 3D laser scanning, photogrammetry, and computer modeling, to study the trilithon stones and the quarry blocks in extraordinary detail. Researchers from universities in Germany and the United States have conducted detailed surveys of the site, attempting to reconstruct the exact methods used. What they've found only deepens the mystery rather than resolving it. Calculations based on known Roman rope strength, wood friction coefficients, and estimated workforce sizes suggest that moving an 800-ton stone would have required a pulling force involving thousands of coordinated workers, an operation of staggering logistical complexity, requiring near-perfect synchronization to avoid the ropes snapping or the stone shifting off its rollers catastrophically. Some engineers have calculated that achieving this with purely muscle-powered systems, while theoretically possible, would have pushed known Roman engineering capabilities to their absolute limit, and possibly beyond what has been documented anywhere else in the ancient world. This is why Baalbek is often mentioned in the same breath as Egypt's pyramids and Peru's Inca stonework, not because the civilizations are related, but because all three sites represent extreme outliers in ancient engineering, moments where builders achieved something that pushed dramatically beyond the typical standards of their era. Some researchers have proposed alternative theories. One hypothesis suggests that these enormous foundation stones might not be Roman at all, but rather remnants of much earlier unknown building phase at the site, later incorporated into the Roman temple complex. This theory points to the fact that no other Roman structure anywhere in the empire uses stones of this size, and asks a reasonable question. If Roman engineers were capable of this at Baalbek, why does evidence of similar capability not appear anywhere else in their vast empire? Critics of this theory point out that Roman construction techniques found throughout the site, including chisel marks, quarrying methods, and architectural styles, are consistent with known Roman engineering practices from the same era. They argue that Baalbek may simply represent an extreme, almost experimental example of what Roman engineers were capable of when given unlimited resources, unlimited time, and the religious motivation of building the largest temple complex in their empire. The truth, as is often the case in archaeology, likely sits somewhere between these positions. An ongoing excavation work continues to refine our understanding. Now let's separate fact from fiction, because Baalbek has attracted no shortage of extraordinary claims over the years. Some popular theories suggest that the stones were moved using lost ancient technology, forgotten machines, or even claims involving extraterrestrial assistance. These theories, while popular in certain corners of the internet, are not supported by archaeological or engineering evidence. There is no physical evidence of technology beyond what the Romans and earlier civilizations are known to have possessed elsewhere. What is true, however, is that the scale of achievement at Baalbek remains genuinely unmatched elsewhere in the ancient world for structures of confirmed Roman origin. This isn't a case of needing supernatural explanations. It's a case of needing to accept that ancient engineers, through sheer scale of labor, ingenuity, and determination, were capable of feats that still challenge modern assumptions about the limits of pre-industrial technology. It's also worth noting that the site was continuously used and modified for centuries after the Romans, including periods of Byzantine, Islamic, and Ottoman influence, each leaving their own architectural fingerprint on the complex. This layered history sometimes complicates efforts to date specific elements of construction with complete certainty, adding yet another variable to an already complex puzzle. So what is the legacy of this extraordinary achievement? Baalbek stands today as a powerful reminder that ancient engineering was never primitive. The methods used here, precision quarrying, coordinated mass labor, ramp and roller transport systems, and architectural planning on a monumental scale, represent an evolutionary peak of pre-industrial construction technology. These same foundational principles, understanding leverage, friction, structural load distribution, and large-scale labor coordination, would go on to influence engineering projects for centuries afterward, echoed later in medieval cathedral construction, Renaissance architecture, and even early industrial era engineering challenges. Modern engineers studying sites like Baalbek aren't just satisfying historical curiosity, they're gaining genuine insight into problem-solving approaches that remain relevant today, particularly in fields like heavy load transportation, structural engineering, and large-scale project logistics management. The site has also become one of Lebanon's most treasured cultural landmarks, recognized as a UNESCO World Heritage Site, drawing historians, engineers, and curious travelers from around the world, all searching for answers to the same question that has puzzled visitors for centuries. As you stand before these stones today, weathered by 2,000 years of history, wars, empires, and shifting civilizations, you're left facing an uncomfortable truth. We built this. Human beings, without modern machinery, without electricity, without computers, achieved something so extraordinary that it still challenges our modern understanding of what's physically possible. Perhaps the real mystery of Baalbek isn't how it was built, but why we so often underestimate what ancient civilizations were truly capable of achieving. So here's the question worth sitting with. If ancient engineers, working with nothing but ropes, wood, and raw human determination, could move 1,000-ton stones across an entire valley and lift them dozens of feet into the sky, what does that say about the limits we assume exist today?